Hello friends, welcome to my channel. In today's topic we will learn pin description of 8051. 8051 family members come in different packages such as DIP, which is a dual inline package, UFP, quad flat package, and LLC, leadless chip carrier. They all are having 40 pins which are dedicated for various functions like read, write, I/O operations, interrupt, timer, serial communication. And in 40 pin IC, 8051 offers multiple functionality. It is offering you the functionalities of 72 pins. So out of 40 pins, 32 pins are arranged in 4 ports. Each port is having 8 pins and each port is having different functionality as you can see here. The rest 8 pins are dedicated for VCC, EA bar, ALE, ESN, crystal, ground, reset. So we will go through each pin in detail one by one. So first in this part we will focus on the pins which is having simple functionality, and in next part we will focus on the ports. So first pin is a VCC pin. The VCC pin is used to provide supply voltage to the chip. The voltage source is plus 5 volt. Next pin is a ground pin. This pin is connected to the ground, which provides logic 0, or which is used to provide a 0 voltage power supply, and that's why it is connected to negative terminal of power supply. Then next two pins are crystal 1 and crystal 2. 8051 is having on-chip oscillator, but to run that oscillator it requires external clock. So most often quartz crystal oscillator is connected to the input pins, which are crystal 1 and crystal 2. The quartz crystal oscillator is connected to those pins with the help of capacitor of 30 picofarad value. So main function of the oscillator is to generate the clock pulses by which all the internal functions operations are synchronized. So basically it is providing you the pulses of logic 0 and logic 1. The next pin is a reset. Pin number 9 is a reset, which is an active high input pin. So when you apply logic high pulse to this pin, the microcontroller will be reset and all the activities within the microcontroller will be terminated, so which is often referred as the power on reset. So once microcontroller is reset, all values in the register are lost, and most of the SFR registers are set to their default value. Like a program counter is set to 0 upon a reset. Okay, it means that when program counter is set to 0, it means when you restart the microcontroller, when you power on the microcontroller, it will start fetching instructions from the 0th location, first location. In order for a reset input to be effective, it must have minimum duration of 2 machine cycles. So the high pulse, so that the high pulse which we are going to apply to this pin should last for minimum 2 machine cycles, then only 8051 will be reset. Next is ALE. ALE stands for address latch enable. It is output pin and it's an active high pin. The main function of ALE pin is used to demultiplex the multiplex address and data signals. So as you can see here on port 0, the alternate function of port 0 is transmitting address and data. So that address and data lines are multiplexed together, and to separate address and data lines, ALE pin is used. So when ALE is equal to 0, the data on port 0 line will be treated as the data, or the port 0 will act as a data bus, and when ALE is 1, the data on the port 0 will be treated as a address. So ALE pin is basically to separate the data which is present on a port 0, whether that data is an address or data. Next pin is a PSEN bar. This is the output pin, which stands for program store enable. It's an active low pin. It is used to read external ROM memory. So this pin is connected to output enable pin or OE pin of a ROM. Why program store enable pin is required? So when there is an external ROM, when you are interfacing external ROM, 16K of external ROM to a microcontroller along with 64 KB of external RAM. In that case, for reading the data from that 64K of external ROM, this pin is used. So suppose, let's assume here one scenario wherein external ROM of 64 KB and external RAM of 64 KB is connected, and both memory locations are having address range from 40 to 4F. So obviously the data which is coming from these memories will be placed on the data bus. But the question is that how microcontroller will come to know from which memory location data is being fetched. So when microcontroller is reading data from ROM memory, it uses this pin, program store enable bar pin, and when microcontroller is reading data for RAM, a read bar and write bar pins are used. So using these two pins, two sets of pin, PSEN bar and a read bar and write bar pin, the microcontroller will distinguish from where data is being fetched, because the address location is same from 40 to 4F for both the memories. So PSEN bar is exclusively used to read the data from the external ROM. Suppose microcontroller wants to read data from external RAM, it will use a read bar and a write bar. Okay, so here PSEN is used for reading the data from the external ROM. Next is a EA, external access input. EA stands for external access input. It is used to enable or disable the external memory interfacing. So most of the 8051 family members come with on-chip ROM to store the program, where program is stored permanently. So along with the internal ROM, suppose microcontroller is connected to additional ROM which is being used in conjunction with internal ROM. In that case, EA bar pin is connected to VCC. Okay. Suppose microcontroller is using on-chip ROM along with some part of the external ROM for storing the program, then EA bar is connected to logic 1. But suppose what happens, some microcontrollers of 8051 family, there is no on-chip ROM, like 8031, there is no on-chip ROM. Or in another situation where microcontroller doesn't want to lose the internal ROM. You just want to rely on the external ROM. Suppose external 64 KB of ROM is interfaced with the microcontroller, and now microcontroller don't want to lose internal ROM. So to discard that internal ROM which is present on chip, EA is connected to logic 0. EA is connected to ground, indicate that code is stored externally. I hope you are clear up to this. So next pins, which are all the pins of port 0, 1, 2 and port 3, will be covered in next video. So stay tuned. Okay, if you really like the video, don't hesitate to share, comment and subscribe it.